In this video, you will learn how to create platforms that fall after the player stands on them. This is useful as a dangerous obstacle in your game where the player will need to think quickly to avoid certain death, as well as potentially creating a point of no return where the player isn't able to backtrack after crossing the platform. Howdy, and welcome to Game Endeavor. Learn practical dev skills and improve the quality of your games by subscribing and ding-a-ling that bell. Undoubtedly, most of us have played a game that have implemented the falling platform as a mechanic. This is an extremely common trope that can easily add a touch of excitement to your game with minimal effort. This is what we'll be creating today, so let's go ahead and get started. Before we begin working on the platform itself, we first want to implement a way of informing the statically challenged platforms that we're standing on them. A quick and easy way of doing this is to use the Kinematic Body's 2D slide collisions to get collision data for anything that we've pressed up against. After our call to move and slide, which we use to move our character, we'll create a for loop saying for I in get slide count, which will return the number of slide collisions that have occurred from our call to move and slide. For simplicity's sake, we're going to store a reference to our collision data by saying var collision equals get slide collision, passing to it the I of our iteration as the slide index. This is the collision data for a slide. It holds information such as what we collided with, as well as the normal and the position of the collision. Very useful information that you can do a lot with. We are now ready to wake up the platform, but first we want to make sure that whatever we collided with actually cares that we've collided with it, which we'll do by saying if collision.collider.has method collide with, which as the name would imply, make sure that there's a method for us to call here shortly. Otherwise, you run the risk of crashing your game. Then, we'll call the method we checked for by saying collision.collider.collide with. We're going to pass into this the collision data from our slide collision. The collision data is from our perspective of our character. However, the platform may want to know information about the character that caused the collision, which the Kinematic Collision 2D does not contain. So we're also going to pass a reference to ourselves should we need it. For this particular demonstration, we're not going to use either of these. However, we may need this for future purposes, because this method has many different uses. We may as well go ahead and make it flexible now. Now we can get started on the platform. I already have a scene prepared which has a Kinematic Body 2D as the root, an animation player which we'll use to shake the platform, and a timer to reset it. There are many different ways that you could respawn or despawn the platform. You could use a visibility notifier for when the platform goes off screen, an area to catch the platform, or even just a distance fallen check. But for simplicity's sake, we're going to use a timer. Make sure that it is set to 1 shot, otherwise it will continuously respawn your platform. The wait time isn't as important since we'll be using an export variable to make it easier to adjust when placing them in our scene editor. For the Kinematic Body 2D itself, you want to have sync to physics enabled so that it interacts properly with the other kinematic bodies. I also have one-way collision enabled for the shape so that the player can jump up through the platform. In the animation player, I have a shake animation pre-made. Note that it causes the sprite of the platform to shake and not the collision shape. We want to visually convey to the player that the platform is about to fall. If we were to shake the collision shape, then we could potentially knock off the player from the corners, which would be frustrating. In the script, note that I have already cached the animation player and the timer. I have also connected the animation player's animation finish signal to the script, as well as the timer's timeout signal. One of the main requirements for a platform to be considered a falling platform is that gravity needs to incrementally displace its position over time. We're going to start with that. For this, we'll need to store the incremental effects that gravity has on the platform. We'll store it in a variable named velocity, which I will initialize as an empty vector too. We'll create a physics process method to handle the physics for our platform, inside of which we'll increment our velocity.y by globals.gravity times delta. Globals is an autoloaded script where I have stored some public variables. This allows me to use a single gravity across my entire game. Use whatever you like. Do whatever I do, and use fancy physics calculations to calculate your gravity. iCard in the corner. Now we need to move our platform, but keep in mind that we have sync to physics enabled for our platform, which means we're not able to use the move and slide or move and collide methods. Instead, we're going to manipulate the position of the platform ourselves, which we can do simply enough by saying position plus equals velocity times delta. And there you have it, a falling platform. Wait, before you go, there are a couple things that we can do to improve its functionality. For starters, if we were to create a ready method, and in it we called setPhysicsProcess, passing to it a boolean of false, this will make it so that the platform doesn't start falling immediately, allowing us to define when we want it to fall by calling the method again but passing in true. We'll get to that later, but first we want to set up the series of events that will lead to that. Recall the collide with method from earlier. This is where we're going to implement that by adding it to our platform script. The first variable I will name collision, which is the Kinematic Collision 2D that we passed in. and the second variable will be named collider, that being the kinematic body 2D that has collided with the platform. Inside of this method is where we're going to trigger the falling for the platform. To be precise, it's where we're going to start the animation that telegraphs to the player that the platform is about to fall. After which the platform falls, a timer resets it, but we've covered this already. My point being that during this, we don't want this to trigger again. Otherwise, it's going to keep playing the animation player and look awful silly. So we're going to create a class variable named isTriggered, which we will initialize to false. This will be what prevents the platform from constantly triggering, by saying if not isTriggered. If for some silly reason you have a completely solid platform as opposed to a one-way platform, and you only want it to collapse when the player is standing on top of it, then here is where you will add an extra condition for that. You want to check the normal for the collision data that we passed in. Before I forget, we're going to go ahead and set isTriggered to true, otherwise we're going to feel pretty silly when our platform doesn't work properly. With that out of the way, we're going to start our animation by saying animationPlayer.play shake. Shake being the name of my animation. Before we finish with this, we also want to reset our velocity here by setting velocity to vector2.0. Otherwise, when we respawn our platform in a minute, it will retain its previous velocity. Once our animation player has finished, this is where we want to drop the platform. Recall that I connected the animation player's animation finish signal to our script, almost as if I planned this out. Inside of this method, we're going to call that fancy setPhysicsProcess method again, this time passing in true, which will start our gravity logic that we implemented previously. Now all that's left to deal with is the respawning of the platform, which we want to do with a timer, so we're going to call our timer start method. I said previously that we're going to use an export variable to set the time for our respawn, so we'll create an export variable named resetTime, which I will default to 1.0 seconds. Lucky for us, the start method has an optional property which determines how much time to put on the clock. We'll pass in our variable here. Here is where the fun begins. Now we need to respawn our platform. Pretty straightforward, but there's a couple of tricks to it. First, let us disable our physics. Once we respawn the platform, it will stop falling and reset just as you found it before you walked across it. We'll do this by calling setPhysicsProcess again, but passing to it false this time. Since we have sync to physics enabled, the platform won't respond to multiple calls per physics process to change its position. If we were to try to change its position here, it would just ignore us. Instead, we need to wait until the next physics frame, which we'll do by yielding, passing to it the scene tree, so that we can wait for the physics frame signal to give us the go-ahead. We're now good to move the platform back, but we're going to need a reference point for where our platform is, so we'll create an onReady variable in our class named resetPosition. And we'll set it to global position, which will be where the platform starts when it is instantiated. And then we can use this variable to set our global position to it after our yield call. However, if the player were to be standing on the platform when it respawns, and for some reason you've allowed this to happen without killing the player, then due to how kinematic body 2Ds work when moves, it's actually going to move the player up with the platform. To get around this, we're going to disable the collision layer for the platform by setting it to 0 before moving it so that it doesn't interact with the character. We're also going to store the collision layer in a temporary variable so that we can restore it afterwards. But keep in mind that sync to physics is still enabled, meaning that the platform hasn't moved yet, so we need to yield for the next physics frame again using the exact same method as before. Once this yield has finished, we can then set our collision layer to our temporary variable, which will restore it. Then we can unset our isTriggered variable so that the platform can fall again. If you want to continue learning practical dev skills, then watch this video on creating perfect moving platforms. And if you're new, then join the sub club to get notified for future videos.